Looking at TPS, the transient plane source method, testing a dry and a saturated sample. Just a little bit of background on the TPS. So as I mentioned, it conforms to the ISO standard. It's a double-sided sensor, which is placed in between two sample halves or two pieces of the material. Your measurement times for a TPS, we're talking seconds to minutes in time scale. So nice option there for relatively quick testing, vastly superior compared to, again, the more steady state options. And specifically for cores, why we are looking at the TPS here, this is a non-destructive method. In this case, we wanted to test the same sample in the saturated state and also in the dry state. So we obviously want to retain the same material for that testing. So non-destructive. And the sample size requirements for TPS align well with even just the kind of your default core sizes that come out for testing in the lab. That even being said, we do have flexibility on our TPS sensor sizes, so there are varying options available. So maybe if you were dealing with somewhat of an irregular material, we can certainly have a discussion around what options would exist to address those. So kind of looking at some of the data here, essentially it was interesting because there was two different samples. There was a sandstone material and a shale. We first tested them both in the saturated state. This was actually, these samples were provided to us by a local company here, which had a specialized pressurization and saturating system there. And essentially what we did, we took the samples both and 100% saturation. You can see between the two, there was, a fairly notable difference in terms of conductivity between the sandstone and the shale, which may not be that surprising. But where we see some very interesting results is that when we go to the dry state and the differences in between those individual samples. So the sandstone here showing a notable decrease, about 22% different compared to that saturated state. Whereas the shale, not so much. There's more, I think maybe 2%, if that. So a very minimal change was observed there. But again, how this has bearing on your design is that if you are, again, maybe making an assumption about the material, testing it in that dry state when actually it is partially saturated or fully saturated, just that alone can result in, almost a 25% shift in performance. So again, understanding the implications of those real world testing conditions are going to be really important.